Hello, everyone, and welcome to today's Energy Storage News webinar with HMS Networks, where we'll be discussing how artificial intelligence and machine learning technologies enable battery life cycle prediction. I'm Andy Colthorpe, editor of Energy Storage News, and I'm very excited that today we'll be talking about a topic that, in many ways, is at the heart of everything the industry does. Lithium-ion batteries have enabled everything from smartphones and laptops to kitchen appliances to work much harder and longer, with the ease of ability to recharge many times over, coupled with high energy density. That has, of course, carried over into batteries for much larger devices, from electric vehicles to stationary battery energy storage systems, or BESS. And after a few years of hard work by the industry and early adopter clients, the energy sector has begun to realize the immense value of battery storage as we move to higher shares of renewable energy and digitalize the operation of the world's electricity grids. Now, that's obviously a gross oversimplification of the complex and fascinating story of batteries and battery storage, but to continue cutting that very long story short, the energy transition presents an immense need for energy storage that will globally surpass a terawatt hour of installations by 2030, according to Bloomberg NEF. It necessitates not just deployment, but operation of battery storage systems on a scale comparable to mobile data infrastructure, almost everywhere, all at once. In our previous two webinars with HMS Networks on data communications for energy storage systems, we have heard about the major headwinds that confront the industry as it establishes global scale. These are challenges for system integration, operation, and optimization. In other words, these are headwinds that can be confronted throughout the life cycle of the project. Today, our speakers from HMS Networks, Matt Schustak and Yuan Li, return once again. This time we're joined also in taking on the theme of overcoming headwinds to battery storage scalability by Jan Figener, who's a battery expert at Acure Battery Analytics. Jan will talk about how cloud-based battery analytics can be used to produce detailed and rich insight into what could be called the secret life of batteries, and how that can create safer, more efficient, and smarter energy transition. Now, as always, interaction with you, the audience, is very important to us. Please put your questions for the speakers in the tab on the right-hand side of your screen, and we will try to answer as many as we can in the Q&A at the end of the speakers' presentations. Now, we'll try and do as many as we can, but we can't promise to answer all of the questions, and HMS and Acure experts will be delighted to follow up and discuss any questions we don't have time for during the webinar and take those discussions offline. We will also be holding a couple of quick audience polls later on, so we'll explain to you how to take part in those once we get to that part of the session. And finally, today's session is being recorded and the video and slides will be available to everyone that's registered. So with all of that and without further ado, I'd like to hand you over to our first speaker, Yuan Li, who is HMS Network's Business Development Manager in Europe and the MEA region.
Thank you, Andy. Hi, everyone. My name is Yuan Li, and today I would like to introduce and talk about the battery life cycle predictions by artificial intelligence and machine learning, together with my colleague, Matt, and also our partner, Yan from Acure Battery Intelligence. So today's agenda, in the beginning, we would like to recap a bit the headwinds that we are expecting for the scalability headwinds for battery energy storage systems. And there are three headwinds that later we will start to talk about. And we would like to zoom in into one of the headwinds, which is optimizations and artificial intelligence of things. And later on, we will also invite our partners, Acure, Yan, to talk about the cloud-based battery analytics. And after that, Matt will come and to describe about how will be the way that we can deploy in an efficient way at scale for these artificial intelligence technologies. And we will using a closing together with the polls and the Q&A sessions to wrap up today's sessions. So regarding the headwinds, we are expecting that the market growth for battery energy storage system will be very significant in the coming 5 years. And because of that, we are thinking that there is going to be a scalability headwinds in the battery energy storage market. The first headwinds that we are foreseeing is that the integration flexibilities in the BESS systems. The integration includes the internal integration between all the components within the battery energy storage system, and also the integration between the external systems like the grid systems, like the energy monitoring systems, external outside from the BESS systems. And the second headwinds is regarding the total cost of ownership. After you have a massive scale of battery energy storage system have been rolled out and implemented geographically in the world, how can be the best way to reduce the total cost of ownership to perform commissioning, provisioning, and maintenance? And the third headwind is that from time to time, after these battery energy storage systems have been put in the field, how we can do life cycle optimizations and to also performance optimization for these systems which is already in the field. What will be the technology we can leverage to achieve that? And if you would like to know more about the headwinds in details, you can go to the Energy Story News website, and there is an on-demand webinar. You can have a look about our last webinar in November. For today's sessions, that we would like to zoom into the third headwinds, which is the performance and lifecycle optimizations. On this part, we are thinking that enabling the artificial intelligence of things can be the best way for future workflow improvement. After you have the technology for data communications within your BESS systems, you can integrate with different protocols, and based on the communication technologies, you can bring the data up to the cloud and to the centralized stations. By that, you can have your data visualizations and also decision-making process. But furthermore, after you have all the big data collected, now you can actually further to perform the training, optimizations, and also predictions by utilizing the cloud AI and data analytics technologies. And furthermore, you can also deploy those AI models back into the field to achieve local inference in the field side on each BESS systems. And today, we would like to have our partners, Acure, to talk about more about the cloud AI and data analytics for battery energy storage systems. So I would like to introduce Yan to give you a more sharing about this part. Hello, Yan, the stage is yours.
Thank you very much, Jan, and welcome to the Acure part of the presentation. My name is Jan, and today I will talk about how field data improves battery safety and performance. So let's have a look at the future and the present. What's going on? On this slide, you see the stationary battery power in gigawatts from 2020 to 2030. And what you can see is that we're just at the very beginning of a big market growth. So Bloomberg New Energy Finance estimates that we will have a battery power of 411 gigawatts and a battery energy of over a terawatt hour. Like, these developments are really crazy, and there's much more to come. The energy transition is built on batteries, so we want them to be safe and reliable. So let's have a look. Although battery fires are quite rare, they still happen, and I brought you two recent examples. The first one you can see on this slide is the Victorian Big Battery Fire, which happened in August 2020, this year, 2022, in Australia. And another one is here, the battery storage in Moss Landing, California, USA, which is just a very recent example from September this year. And although these fires are quite rare, people lose trust in the pillar of clean energy, and it makes it harder to deploy electric vehicles and stationary storage for the integration of renewable energies. So You can have three solutions to face this issue. The first one is you can improve production quality. But this is very difficult because you have billions and billions of battery cells being produced, and to have them 100% flawless is nearly impossible, even though you're very, very good at production. The second solution is you can build resilient system designs. For example, you can have fire-proven boxes, or you can choose very safe battery technologies and chemistries. But of course, this comes with a cost. And the third option is advanced data analytics, and I want to talk about it today because this is the core of what we do at Acure. We are currently having 1.7 gigawatt hours of battery storage monitored, and we cover the whole battery storage markets. So we have stationary energy storage, electric mobility, and also a battery production under monitoring. Right now, we have 80 employees, and we are growing strongly. So in case you are interested in battery diagnostics and want to push forward the energy transition, just feel free to reach out. We have two offices. The first one is in Germany, and the second one is in the USA. Within our portfolio, we cover all major battery manufacturers. So just to name a few, LG Chem, Samsung, Panasonic, CATL, Kokam. So we have a good overview about what's in the market and what's best to buy and what's best to operate. In general, we have a data flow that is on this slide. So on the left-hand side, it starts with a BMS. You have a battery management system that measures current, voltage, and temperature. These values are then collected by a SCADA system and sent to a cloud. And the cloud is where our work starts. So we have a cloud platform where we do some battery magic and do some nice analytics to evaluate the lifetime of the battery and the safety, and also the performance of the overall system. So in the following, we will talk mainly about this cloud analytics. You may ask, okay, if I have a battery management system, why do I need the cloud? And the answer is quite simple. A battery management system has limited capabilities of calculating and also of storing data and evaluate historical data. So what it really does, it just reacts to actually occurring issues, like if the voltage is too high, stop charging, or if the current is too high, reduce the power, something like this. So you can just operate rule-based and logic-based rules. The cloud is now responsible for storing all the data, cleaning it, and then you have access to the whole historical data and can do more analytics. So you can have more complex and advanced models. You can compare single systems with the whole fleet, and this enables you to gain very good insights, and you can proactively handle anomalies. You can use big data approaches and also forecast because you have access to so much data. And I want to emphasize that it's not enough to always rely on the battery management system. Of course, in general, batteries are quite safe and the battery management systems do a good job, but we also see some systems that don't work as promised. What you see on this slide is the voltage over a couple of months. And you also see some lines. We will go through that step by step. So this battery was specified by the OEM to have an end of charge voltage of 4.15 volts. And then the data sheet of the battery manufacturer states the end of charge voltage is 4.2 volts. This is the yellow dotted line you see on that slide. So the voltage should never exceed this 4.2 volts. We see at the very beginning, when we look at the left-hand side, that it works quite well. But after a time, the voltage level was exceeded, and the voltage, the end of charge voltage, raised, and it was also below 4.3 volts. And this is safety critical. So we talked to the OEM and said, hey, it's sometimes going over 4.3 volts. And they said, this is not possible. But if you just look at this quite easy analysis, you see these things are out there and we have to be aware of it. The second example is for monitoring of performance. And when you buy a battery storage system, you usually get a power curve of the system as a function of the temperature. So with very low temperatures, we have low power. With high temperatures, we have low power. And with some medium temperature, maybe room temperature or a little bit less, we have maximum power. And this system was specified by the maximum charge power curve, which is shown here in black. When we evaluated the system, we saw, okay, what's actually happening is the yellow dots. So sometimes you're not getting even half of what was promised. And this can be a big issue because when you promise to deliver power at the spot market or at the ancillary service market and you don't deliver, it can be very costly for you. And worst case, you can even be disqualified if you don't provide ancillary services you promised to do. So what we did is we confronted the OEM. He updated the battery management and energy management system. And as a result, we now have the blue dots. So you see, it's not completely following the line, but it improved the situation a lot. The first two examples I talked about were quite easy because they were just a single system analysis. And now I want to take you to have a look at how we empower the power of big data. On this slide, you see the battery impedance over time, and you see a couple of lines. These are all cells that are in a module. So what do you see? We see that the line goes up and down, and there might be some issues, but we don't really know for sure. So you see, for example, here some changes. This could be temperature or SSC dependency. Another thing could be noise. We recognize that all battery management systems have their individual noise, and it's very important to get rid of this. Then you can maybe see some trends, maybe some aging trends with a rising impedance, but you never know, like, should I take these outliers into account or not? So that makes it quite difficult. And then we see some steep rises of the impedance, and this could be safety critical events. But as you see at the first one, it goes down again, so it was probably not safety critical. The thing is, it is quite complicated. So let's apply the power of big data diagnostics to unlock the potential of safety analytics. What you see on this slide is a single system. So let's just say we have an exemplary system and it operates within a range like of temperature and also of different states of charge. So we operate the system, the temperature changes, we have some operational profile at different states, and we can then identify some interesting diagnostic features. This can be a relaxation phase, or for example, how the voltage reacts to a steep rise in current and something like this. So you cannot use the whole data, but you can find some really nice parts where you can do good analytics. But of course, like this temperature state of charge room is still quite empty. So we take a second system. Maybe this one is operated at colder conditions, so we can also have take these into account. Then we have a third system. Maybe this is operated at hotter conditions, so we get the red points, and then we get a couple of average operations. So what you see is that the dots fill more and more of the temperature state of charge room we need. So this is just 4 systems. And then we can come, for example, to 100,000 systems and do all this analytics for 100,000 systems. And what happens then is that this map that was quite empty at the very beginning because we just had a couple of systems is full of information. Like we gained all the insights from the single system, put them together to an overall knowledge for the whole fleet. And with this knowledge, we come back to the single system. So you see here that we have the battery impedance as a function of the temperature and the state of charge. And what is very important to get from this slide is that it is dependent on these variables. So especially with low temperature, the impedance rises, and we need to take care of it. So after creating this very nice surface plot, we can then come back and smooth the data. So let's have a look. What did we see before? We saw this very noisy data and we didn't know how to interpret it. And then we apply the analytics from the insights we draw from the previous slide, and we can see that we are able to really smooth these curves. So we see that everything was noise except for the very last rise in impedance, which is on the right-hand side. And this really was a safety critical module. So we took it out of the field, we tested it in our labs, and it was indeed a problem. So we were able to handle the situation due to big data analytics. So let's finish with a success story of safety analytics. And for this, I want to talk about a story which happened within this year. So one of our customers, which is Zenec, has a fleet of 65,000 home storage systems. And it happened that in March, 3 of these systems exploded. I can talk about it publicly because it was in media, and we also announced in media that we work together. So Zenec acted quite responsibly. They shut down the whole fleet to see what went wrong and to do some analytics to find the reason. So their engineering team approached us and we worked hand in hand together on a new safety product and were able to identify the reasons. So we checked the whole fleet, took some other systems out, and then Zenec was able to put the whole fleet back into operation again. And I think that is very, very important to see how cloud analytics can really help in reality. I mean, the houses were burned, and even the roofs were lifted up a little bit, and there was smoke everywhere. So that's really important that we have very safe and reliable energy storage systems. At Acure, we have 3 products, and maybe you see that one fits for you. We have the safety manager I talked about today. We have the performance manager. That was the example with the power curve. And we also have a lifetime manager, so we can help you operate your system so that it minimizes aging and maximizes revenue. And we also cooperate with insurances. So if that is interesting for you, just feel free to reach out. So I want to end my thought with a talk with a very short summary. Cloud analytics are very important at the moment and will also be in the future. But what we can also do is we can bring back intelligence from the cloud to the hardware. And here we talk about edge AI deployments. I'm very happy to hand over now to Matt and to hear more about it.
Yes, thank you, Jan. That was, I think, some really interesting stuff, and I think you conveyed quite well the power of the analytics and machine learning that your teams have applied specifically to battery applications, and actually really showed some good examples of the types of insights that you can generate. To zoom back out and kind of close things off, I'm going to return to our sort of headwinds analogy and reference the AIoT diagram we've been sharing. And again, the real headwind, so to speak, that we're referring to here is it's about efficiency at scale. So with hundreds of thousands of BESS systems needing to be deployed in just a few short years, we're going to need to leverage some advanced tool chains in order to maximize the value of this intelligence that we can generate. So if we break this full sort of process down into individual steps, from a market capability standpoint, you can see we do have a lot of it covered already. So, for example, getting BMS data into the cloud is, generally speaking, not a huge challenge. The access to the data is there. The transmission methods are there. And as we just saw, From Acure, there are a lot of proven and powerful solutions that leverage the cloud computing and machine learning to generate some valuable business insights, you could say. But for the last step, which is effectively taking action on these insights, there is basically a fork in the road, because these two different these actions fall into basically two different categories, you could say. So on the one hand, the action could be something that's more sort of binary, such as like a safety hazard, which could typically be handled via the SCADA. So for example, a flag can be set to indicate a potential safety risk, and the system can be taken offline. So we're using basically a traffic light symbol here to indicate this type of action. And we're giving this the good old thumbs up, because effectively the capability already exists today to achieve and implement this functionality efficiently at scale, right? However, in many cases, the action might be something effectively that requires a software update somewhere within the system. And this could be as deep as, let's say, the BMS level, or perhaps we're talking about updating a local inference of an AI model of some kind. Now, regardless of the party who's responsible for this, for efficiency's sake, at scale, this is effectively going to require an over-the-air update functionality, right? And likely in a more automated fashion. Again, it's the scale that we're talking about here. Now, Azure IoT Edge and AWS Greengrass both offer software modules to sort of facilitate some aspects of this, but in most cases, some additional sort of purpose-built edge hardware may also be required. Now, this is obviously a very interesting topic within itself, with a lot of different technical aspects of security and otherwise, and we could likely, dedicate an entire webinar to this topic. But for today's sake, we're gonna use the group discussion icon basically to indicate that this use case overall can absolutely benefit from further discussion and further collaboration going forward. I think we can probably all agree on that one. So to close it out, I felt it's worth noting that HMS offers numerous flexible edge products to help customers formulate sort of purpose-built solutions to exactly these kinds of problems. But the HMS sort of value add really goes beyond intelligent hardware. We also have an in-house software and cloud services development team whose primary focus is really helping customers complete the full tool chain. So really leverage the hardware, leverage the cloud capabilities, complete the entire tool chain. So we encourage you to reach out, share whatever challenges you're facing, maybe now or maybe what you're anticipating in the future. So thank you, and back to Andy, I think.
Fantastic. Thank you very much, Matt, and of course to Jan and Yuan as well. So lots of questions coming in from the audience. Keep those coming in. As I say, we'll not be able to answer all of them during this session, but the experts at HMS Networks and Acure will be happy to follow up with every single one of you that asked a question, and yeah, hopefully get that discussed or explained and answered to your satisfaction. So before we go on to that Q&A, got a couple of polls here for you all that we'd like to canvass your opinions on. So poll number 1 is, I guess, more on the Acure and life cycle of the battery kind of side of things in terms of data communications as a topic. So, dear audience, how do you currently monitor the health and life cycle of your batteries? And please pick one option. The drop-down box should be in front of you, popped up on your screen. If it isn't for some reason, there is a box you can fill in your answer in the polls tab on the right-hand side. So is it A, not at all? You don't monitor the health and life cycle at all. It's not enough of a high priority for you. Not at all, but we are currently investigating options. Are you currently relying on the battery energy storage system provider, or OEM, for the monitoring? You could say D, we have our own internal data collection and analytics. E, you might outsource that to an external third-party partner. Or possibly F, if you don't have any batteries, I guess you probably don't monitor the health and life cycle. So therefore, you would select that option. So yeah, we're going to give the audience a few seconds to consider and answer this. But what would you kind of broadly expect the audience to be? And I suspect your answer might be to encourage them to outsource to a third-party partner, such as perhaps Acure. But yeah, realistically, what would you expect people's consideration at this stage of the industry development to be, do you think?
I think we will see all answers. So maybe if we just go through them, if we have a company that is just building up a battery storage, maybe a startup in the commercial sector or anything like this, they might have not the priority on battery analytics right now because they want to finish their product. So the priority might be not high enough. If we look at B, then I think we have already established companies that have systems in the field that have collected a lot of data, maybe faced some first issues and see, okay, what can we do about it? Do we do it ourselves or do we go to a third party? Then we have C, that are also probably established companies that just use some products provided by the OEM, for example. And then maybe some big companies, if we think of the automotive sector and so on, they will probably have their own, they have their own data analytic teams. Then we have some maybe smaller and medium-sized operators, or for example, operators that have not many systems, but very big systems, if we talk about the utility scale. So they will most probably not have their own data analytics, and they then reach out for third parties. We have that in the home storage sector. We have that utility sector and also some automotive companies. And of course, people will also be here that don't have batteries. So probably some will also pick F. So I expect a broad range of answers.
Of course, and then those folks that don't have batteries yet, in some ways, they're just as important as the rest, because I guess they might be at an earlier stage of their sort of decision-making process around that, I suppose. But okay, cool. So just looking through those answers now. All right, so having said that they're still important, we're going to kind of discount the crowd that do not have batteries. So there's about 28% of respondents. And just to say, by the way, very high level of engagement from the audience. So thank you very much for participating so quickly in the short time. Can still see a few votes are still coming in, but we'll take the results more or less as read for now. So we do not have batteries was 28%, but folks with their own internal data collection and analytics was actually level with that. So a lot of those big players with sort of in-house capabilities. Those that rely on the BESS provider or OEM was at about 25%, so about a quarter. So close to those that have the in-house, but slightly lower figure. And the folks that have no monitoring at all but are currently investigating options represents 11% of respondents. Those who outsource to an external third-party partner, just 5%. And those folks that say not at all, it's not high enough priority, 3%. So broadly in line with what you'd expect, I guess, Jan?
Yes, I think it's in line with of what I expected.
Okay, cool. Excellent. And so moving on to poll number 2. And so this is kind of more on the data and communications networking side of things. So if we could have that launched, thank you very much. So you should have the options again, drop down box, same drill as before on the screen in front of you. So which data and communications challenges do you anticipate regarding the large-scale deployments of an AIoT solution of this nature? and you can pick any of the options from here. I believe you could go multiple with this particular one, and the options are A, accessing relevant CAN bus data from battery management system level. Is it B, filtering and or interpreting the relevant battery or BMS CAN bus data? Are the challenges you anticipate coming from transmitting data to and from the cloud? Or perhaps instead you think it's going to be on a more local level and you see a local deployment / local inference, setting up of those as the main challenge? Or do you perhaps think that there is another challenge and therefore none of the above, which would be option E? So Matt, just want to get your thoughts on this because this is kind of your area really, I guess. What would you kind of expect to see from our audience today, do you think, if it's a tough one to call?
I have to say I'm impressed and eagerly watching the results. I mean, this is a sort of a hot, not a debate topic, but each of these can be challenging. It really depends on how you look at it or where you fall in the I guess value chain, right? So or your perspective, I guess is the best way to put it. So I would have guessed that the final step that we talked about, the local inference, actually leveraging, let's say if you actually are deploying an AI model at the edge, completing that full sort of full chain, in my view, is let's just say challenging. There's a lot of different aspects that are challenging there. So I expected that would be kind of clearing away, but it doesn't look like that's the case from the audience perspective. So really interesting.
Okay, cool. Yeah, so I mean, just in that short time, nearly 200 votes in there. So again, thank you so much for your engagement. That's really really high engagement, and I guess we can probably consider, rather than wait for the rest of the 1,000 attendees to vote in on that one, I guess we can probably extrapolate a little bit from this sample size, Matt. So yeah, looking at those results now, the local inference and local deployment was a major concern, but it wasn't the number one. So in top was filtering and or interpreting the relevant battery or battery management system CAN bus data. Those challenges that kind of you guys are familiar with and would have expected to come near the top then?
I had to throw this over to the Acure team because, I mean, obviously that's a piece of the puzzle that they have solved, digging through and filtering and knowing exactly what to look at, what's the most meaningful data to use.
Yes.
I'm not going to talk about the methods, but
No, definitely. So what was the percentage on B?
For B,
30%.
we were 32. Sorry, so let me just do the full result rundown then, and then
Yeah.
we'll take it from there. But yeah, so filtering and interpreting relevant battery BMS CAN bus data, 32%. So by far the biggest wedge. And then neck and neck actually were the other three options. So transmitting to and from the cloud, local deployment, local inference, and accessing relevant CAN bus data from BMS level. We're all pretty much level on 18% or thereabouts, a little bit of movement there. And then none of these, kind of curious to know what those folks did think were the challenges. But yeah, none of these was 14%. So yeah, so top was filtering, interpreting relevant battery BMS CAN bus data on 32%, yeah.
Yes, that sounds amazing. So just reach out to us because this is exactly the reason why we founded Acure to tackle this issue. And I'm very happy to see that it is also broad in the industry that this issue really exists. I think that is a very good result for us.
Excellent.
If
Okay.
only we had to ask some follow-up questions. I love these polls, but it's unfortunately I'd love to discuss further with the audience to get their perspective here.
Yeah, of course, and I'm sure. Well,
Possible.
no doubt you guys will welcome approaches from the folks that registered, and so yeah, you can get in touch via your registration form, and if you did ask a question, HMS will be reaching out to you to see if you want to continue that discussion on further. But talking discussions and talking of the opportunity that we do now have, let's do a few questions from the audience, guys. I hope you're ready and primed for these. I've tried not to pick anything too challenging, but it is a question of having you on here for your expertise, so do prepare to perhaps be challenged. All right, so we'll start with one for Jan, actually, from Giorgio in the audience, who was, so Jan, you showed the modeling of the battery, and there's the graph with the, excuse my non-scientific language, the squiggly lines with the points of interest
Yes.
marked out on it. So I'd imagine this is, again, something really complex that points of interest kind of covers. But Giorgio wanted to know, broadly speaking, what you meant by those points of interest. What are kind of the outliers in that sort of data?
Yeah, sure. So when you operate a battery, you have different states of operation. And for example, for many analysis, you need the open circuit voltage, which is measured when the battery has some phases where nothing is happening. Then the voltage converts to a steady state, which is called open circuit voltage. And then you can use this open circuit voltage, for example, to build something like electrocardiogram you do for hearts to see how healthy a heart is. And you can do the same with the open circuit voltage for batteries. And that's, for example, a feature of interest. So we're looking for relaxation phases where we have the open circuit voltage, put it together, and then can see what aging mechanisms took place. So that's, for example, one type of feature of interest. Or if you have a very high current occurring from 1 second to another, then the voltage reacts. And we can also, out of this reaction, we can also gain insights about how healthy the battery is, for example. Just imagine you starting running and your pulse goes up and up. So that's also happening to batteries. So that's what we do.
I guess that's why it's called state of health, huh? Yeah.
Yes.
Okay, great. And so there's a question that came in from Kandup in the audience, who was asking what the increase in total cost of ownership is by adding AI and machine learning in existing BESS. Now, I'm guessing that the answer is that the idea of adding this stuff is essentially to lower the total cost of ownership, but I guess there's always an outlay involved with any sort of upgrade that you might make. So yeah, so what would you guys say is the change in total cost of ownership that comes with adding these types of solutions to an existing BESS? I'm not sure who's best to tackle this one. Whoever'd like to go first, really, I guess.
I think it's a great question. To your point, Andy, yes, the ultimate goal is absolutely to reduce the TCO through investing in maybe some small, let's say, hardware, some small design cost increase. Again, at the end of the day, the cost is sort of negligible. The addition of this, let's say, a gateway, a dedicated little piece of hardware, relative to the total cost of the system is very small. But if applied properly with the right tools and in the right way, can dramatically reduce the TCO, at least from our perspective. When you think about owning, maintaining, servicing, long term, that's what we're talking about, the total cost of ownership, all of this combined, even if that cost doesn't necessarily just fall on, let's say, the BESS integrator, somebody has to absorb that cost. And so we're talking about hundreds, thousands of systems. That tiny cost increase of the piece of hardware and let's say the services associated, it's negligible, really, at the end of the day.
Yeah,
Yes.
and also I also want to add that for putting the artificial intelligence machine learning on the BESS system is not only look at reducing the total cost of ownership. Yeah, of course we can achieve that by using the artificial intelligence to do some predictive maintenance. However, another part we can also look at is how you will be able to generate additional revenue stream for your technologies, for your BESS systems, because you can start selling like different type of service contract for your installations in the field, and also you will have a different value propositions compared to the other BESS system integrator and manufacturers, because you can have different guarantee to them on the BESS system you are installed for them. And if that is going to become some regulation in some country or in some specific sectors, that can be a very different value for you to present in the market. Yeah.
Yeah, thank you very much. I can just confirm that I'm 100% with you. I mean, sure, you add a little bit of cost due to analytics and maybe some hardware things for if we talk about edge AI deployment in the future, but still you can reduce the maintenance costs and so by a lot, and you can really check, does my system have the performance that was promised, and things like is it working well? What's about the aging? Do we need to adjust the operation to lower the aging and so on? Like these things are just possible with analytics. And if you just scroll through media, you find recall actions in the automotive sector up to $2.3 billion for a recall action where cars catch fires. So that is, and just think of the image problems and indirect costs that adds up to these 2.3 billion. So there's, I think, a lot of potential to reduce the total cost of ownership.
Right. I mean, I guess the other side of that is that, as you mentioned, like Acure and I presume other providers work with insurers as well. So I presume there's a big sort of de-risking piece, in terms of, particularly for new projects, I guess.
Yes. So, for example, it makes investment decisions also easier. So if you want to invest in a big solar park and a big battery storage system, you want to make sure this investment is safe. And you have typically run times of 10 to 20 years to reinvest the whole park and so on. And with the solar systems, we're quite advanced. We know like these systems, they last for 20 or 30 years. But with the battery, like this is some problem because the batteries, we don't have that many old batteries. So if you have analytics and you cooperate with an insurance, then you can take this risk away from you because the insurance covers it because of battery analytics. And like this product, for example, we offer, and that helps investors to also invest in battery storage systems.
Cool. Okay. Now, look, we've just got time to do a couple more of these questions, I think. Would love to do a load more of them, but let's see where we get to. So Alberto in the audience, thanks for your question, Alberto, asked how to manage the huge amount of data generated in a large battery energy storage system in terms of local and cloud storage, sampling and transmission. Alberto says, surely this can lead to both cost and performance challenges. And maybe slightly exasperated sounding question from Alberto, or don't know if he's actually dealing with literally reams and reams of data, but it does sound like a lot coming out of these installations. Anyone got a viewpoint on that side of things?
I have a question to that question. My question is for Jan, because well, I mean, I guess there's different sampling rates, there's different amounts of data, but can you quantify generally how much, if some kind of number, how much data you actually want to extract, let's say, from a BESS system per the size in some way? Is there any metric for that?
Yeah, so of course you have a trade-off. Like the best from a scientific point of view would be to have maybe a sample rate under a second, and then every voltage, every cell, every measured value. Like this would be best for analytics. But of course we come to a point where the extra added value from a better sample time and a better measurement is not big enough. So usually best sample rates are up to like a second or maybe a minute if it's not possible to get to better sampling rates. And then you can choose, like if you want to have very detailed analytics on the cell level, we need cell data, but we can also work with module data or pack data. And if you, for example, decide to go for a module data, it would be good to have the highest voltage, the medium voltage, and the lowest voltage, just to get an idea of what's happening in that module. So yeah, that really depends on the storage systems and like the analysis that the customer would like to have.
Yeah, I also want to add on top of it is that in the beginning, if we want to do the data analytics, we always need data. But in the entire cycle we were discussing is also including the local inference. So why local inference can play also very important part is actually the cost saving. So in the beginning, you can start collecting a lot of data with a very lower timestamp. But after that, if you have a standard artificial AI model already, you can install them back into the field site. So which means for the future inference, it's only filter out the important learned data and send it to the cloud. So it can help you to save the cost for your data transmission cost. And you can also identify some model site, which is relevant for your entire project. Maybe you have 100 locations, you can identify 5 locations, and these 5 locations, you can continually collecting data. But the rest of 95, you can just leave it because they might have the same pattern with those 5 model sites. And that is why the entire cycle for the optimization will be very important also together when the edge AI can also be implemented.
Excellent. Okay, so go on. Sorry, Matt.
I'm just saying it's about quality data, not just pure quantity. Right? And you can leverage the AI and the edge models to do the pre-filtering and optimize the pre-filtering. Right. That's what we're talking about. Efficiently at scale. That's exactly how to deploy it, or to leverage it, I should say.
So not just big volume data, but big good quality data, I guess. So final question for today, and it was always going to be arbitrary what the last question was going to be. So I am sorry to everyone
There's tons of good questions.
20 or more. Okay, we would be here for the rest of today, unfortunately, to answer all of them, possibly a bit longer than that, I think. But Paul Pereira asked a question so we're talking about quality assurance, and I think, Jan, you did mention that, in the 3 ways you can improve batteries, the first one would be production quality assurance. And Paul asked if you can use diagnostic data from battery production to enhance quality of batteries. So I don't know if you guys each have a view on that, or if you want to use this as an opportunity to just give your concluding remarks as well. But we'll just go around and see if you've got any thoughts on that.
Yeah, sure. We also work with production data, and you can see a lot in production data, of course. So just talking about formation processes and things like that, if you collect the data, that helps to identify weak cells before putting them into a car or into a stationary storage or whatever. So of course, doing analytics at production sites is key for having a very good quality, like in the first period. But over time, also small inhomogeneities and so on lead to aging, and this is accelerating over time. And if you have 1,000 batteries, then maybe 10 will just make a couple of 100 cycles, and the others will make over 1,000 cycles, and so on. So even if you are able to pick out all the weak cells right after production, where battery analytics is also key, you would need a monitoring during operation life, because of cells are just different and very complex, and they never behave all the same.
Excellent, thanks, Jan. Matt, Yuan, do you have a thought on this from an HMS perspective?
So I apologize. Which question were we referring to? I got a little lost.
Oh, sorry. So Paul's question on okay, if it's not apt, then choose a question of your liking. But Paul was asking if you can use diagnostic data from battery production to enhance quality of batteries.
Yeah, great question. the answer is yes, absolutely. I guess just to sort of piggyback on what Jan was saying, HMS really comes from the end of line manufacturing, the automation side of things. That's really our home. That's where we come from. And we have a number of, I would say, already purpose-built solutions to address that type of a use case, right? So you could say merging the automation process, the automation communication, so the field bus, PLC, traditional manufacturing side, and also the IoT data collection type use cases. So we can do both of those things at once through the same piece of hardware, the same gateway, the same intelligent device, so to help facilitate that exact type of use case effectively.
Yes, and I think it's a huge market in the future. There's so many gigafactories announced, so there's a lot to do with production sites.
Lots of work to be done.
Yeah.
Yes.
Absolutely, absolutely. In Europe and in the Americas, and well, everywhere else too, I guess. Fantastic. Yeah, it's a global energy transition, and we're glad you could all join us from wherever in the world you are today. Just want to say thank you once again for the hundreds of people that joined today's session. And as mentioned, your questions will be followed up by the teams at Acure and HMS. Very much hope to see you again in one of our webinars soon. Thank you, everyone, for your time today. All the best.
Thank you very much.
Thank
Have
you.
a nice day.
Have a nice day.
Thanks.
Cheers.
Cheers.